Good morning, class. How are you today? Yes, okay, that's good. You're all wonderful and excited for today, yes? That's good. So, before we start, let's have a prayer first. May I request Miss Leia to lead the prayer? Amen. Now let's settle down. And for our attendance, very good. No one is absent today. Let's clap our hands. Let me remind you for our classroom rules. If someone is talking, please don't speak up or don't have to chat with your seatmate. Second, if you have any clarifications, questions, just raise your left hand. Okay, class? Okay, good. Now, are you already excited to learn something today? So, for today's lesson, is all about stars.
Class, let me present to you our learning objectives for today. At the end of the lesson, the students should be able to first, explain the factors that may affect the brightness of a star. Second, appreciate the colors presented as to its significance in determining the temperature and brightness of a star. Third, draw and illustrate the differentiation of stars to one another. But before our discussion proper, let's have an activity first. It's an experiment observation and it's called Let There Be Light.
Okay, class, are you ready for our activity today? Okay, good. So let's go to your groups and read the materials that I have listed yesterday. The incandescent light and light dimmer. Are all groups ready? Very good. Now let's start. First, plug the incandescent lamp to a light dimmer switch. Are all the incandescent lamps plugged into a light dimmer switch? Okay, very good, class. Now let's darken the room and turn on our lamps. Okay, so let's adjust the dimmer switch slowly until the bulb becomes dim. Okay, very good. All of you got it. Now let's observe and note the color of the glowing filament. Please take note what you have observed in the activity. Are all groups have wrote down their observations? Okay, very good. Now let's go to the second one. So let's adjust the dimmer switch up until the bulb becomes brighter and brighter. Again, let's observe and note the color of the glowing filament. Are you all done? Okay, class. That's very good. Okay, class, let's settle down to our groups. As we have done the activity earlier, we have come up with these results or with these pictures of dim light and brighter light. So now let me ask you, what do you think is the relation of the activity we have done to stars? Yes, Miss Castro? Okay, that's good assumptions. Yes, it's related to the brightness of stars. So are the stars same in size? Yes? Are you sure? Okay, let's debate on that later. Color. Are the stars same in color? What do you think? When you look at the night sky, are the stars same in color? No? Yes? Are they actually bright? Or are they equally bright? They have the same brightness? No? Maybe? So what do you think are the factors that may affect the star's size, color, and brightness? Anyone? Miss Kagampang? Okay. You think they differ from one another? They differ in sizes, in color, and brightness. Okay, that's good. Now let's explore and have a knowledgeable journey. So what is star? A star is a massive ball of plasma that emits light throughout the universe. Stars are huge celestial bodies made mostly of hydrogen, helium, that produces light and heat from the churning nuclear forges inside their cores. So there are five basic characteristics of stars: mass, color, surface temperature, size, and of course, brightness. So let's talk about the color of stars. Well, actually, class, a star's color depends on its surface temperature. The cooler stars tends to be redder in color, while hotter stars have bluer appearance. So stars, the redder the star is, the color it is. The bluer the star is, the hotter it becomes. So stars in the mid-ranges are white or yellow, such as our sun. But stars can also blend colors such as red-orange stars or blue-white stars. Okay, class, do you get it? So let's talk about brightness. There are two characteristics that define brightness of a star. It's luminosity and magnitude. When we say luminosity, it is the amount of light that a star radiates. The size of the star and its surface temperature determines its brightness. When we talk about magnitude, there are two types of magnitude that defines the brightness of a star. It is apparent magnitude and absolute magnitude. But what are the distinct characteristics that differ apparent magnitude and absolute magnitude from each other? So let's talk about first the apparent magnitude. The apparent magnitude of a celestial object, such as a star, is the brightness measured by an observer at a specific distance from the object. When it says specific distance from the object, it can be from the Earth, it can be from Mars, it can be from the distance between a specific star from Earth. That's apparent magnitude. And the smaller the distance between the observer and the object, the greater the apparent brightness is. So let's talk about absolute magnitude. The absolute magnitude is how bright appears at the standard distance of 32.6 light years or 10 parsecs. So the difference between apparent magnitude and absolute magnitude is that apparent magnitude has specific distance, while absolute magnitude has a standard distance that needs to be taken care of. Okay, class, do you follow? Okay, very good. For example, in the table is placed a red dot, and Lisa is 20 meters away from the table where the red dot is placed. So can she see clearly the red dot at the table? Okay, no, she can see clearly the red dot at the table, but when she is 5 meters away from the table, can she see it? Yes, she can, and that's apparent magnitude. The smaller the distance between the observer and the object, the greater can she see or the greater the apparent brightness is if we talk about the stars. Surface temperature. Astronomers measure a star's temperature in Kelvin scale. 0 degrees in Kelvin scale is absolutely negative 273.15 degrees Celsius, and that is very, very cold to us humans. Fun fact. So the coolest and reddest stars are approximately 2500 Kelvin. That is, if we convert it in degrees Celsius, it is 2226.85 degrees Celsius, which is very, very hot. While the hottest stars can reach 50,000 Kelvin. Imagine, the coolest star is 2500 Kelvin, and to imagine 50,000 Kelvin at hot stars, it can be very, very hot. So our sun is about 5500 Kelvin in size. The star size, astronomers measure the size of a given star in terms of our sun, our sun's radius. So one solar radii is equal to the size of our sun. Thus, a star that measures one solar radii should be the same size of our sun. Imagine if there is a star, we name it Rigel. If it has the same size of our sun, it is measured one solar radii. Do you follow, class? Okay, that's very good. So now let's move on to mass. So a star's mass is also measured in terms of our own sun, with 1 equal to the size of our sun. That is called solar masses. For instance, the star Rigel, which is larger than the sun, has a mass of 3.5 solar masses. You all have a good time learning today, class? Yes, excellent. So now let me ask you some questions about our lessons for today. Okay, number 1. Which star is hotter? And which star is cooler? Anyone from the class? Yes, Miss Leia? Okay, you're correct. The red star is the coolest star, and the blue star is the hottest. Oh, let's proceed to the second one. This is the term called for the amount of light that a star radiates. What is it? Anyone from the class? Yes, Mr. Brian? Yes, that's correct. It is luminosity. The third. This is the brightness rather, measured by an observer at a specific distance from the object. Yes, Miss Elpidang? Yes, it is apparent magnitude. 4. If a star named Cyst is twice the size of the Sun, what is the measured size of this star? Yes, Miss Lauren? Very good. It is 2 solar radii. But how about its mass? Okay, very good. It is also 2 solar masses. Let's clap our hands, class. You all have done good today. I know you learned very well our topic for today. And for your assignment, with your groups using the materials listed below, make a group of stars that is different in sizes and colors. And when it's done, provide a 250-word reflection about what you have learned today and its relevance to the stars that you have made. And that is to be submitted, or rather presented, next meeting. So, class, that's all, and thank you for listening, and goodbye.